Okay, gang, 1.9, number 27. Now remember, part A is a verify, not a find, right? So it's different procedure. So verify is a composite. And you've got to show that it equals to x. So I'm going to do this version. Again, technically you're supposed to do both, but for the functions we're going to look at, you could just do one side. That's good enough. All right, so I'm going to do the f composite g of x. I'm going to show that that equals to x. All right, so I'm going to take all of g and shove it into f. So the shell function looks like this. The shell function looks like this. And remember, we're going to put g in where x was. Alright, so there's me putting g into f. Now let me just take it out of the box form in case somebody doesn't like that. So you're going to do the minus, you're going to combine like terms. So the minus 5 and the plus 5 cancel. Now you're going to take the square root of x squared and you're going to get an x. Alright, now in terms of the graphing, I'm going to plug in, let me just see if I happen to have a calculator close by, do I? Alright, hold on one second here. I'm just seeing if I got a calculator anywhere, and I do, which is great. Okay, and the reason I wanted a calculator is because I'm going to use like I don't want to call it the vertex, but like where this starts, this is 5 units to the left. So I know at -5 it's 0, which is, we could also think of that as the x-intercept. And I also want to do the y-intercept. So if I let x be 0, I'm going to have the square root of 5. Right? If x is 0, I'm going to have the square root of 5. But I wanted to approximate that. And that's a really good point to have because that's your y-intercept. So I'm going to hit the square root function, I'm going to put in a 5, and I'm going to get about, I'm just going to do 1 decimal place because it's way too difficult to graph anything farther than that. Just if you need any other thoughts here on this f function, we know that a square root function looks like a hook. Alright, so when we graph this, it's going to look like a hook. So it shifted 5 units to the left. I'm going to approximate 2.2. And we know this looks like a hook. So there's your f of x. Now I can just technically swap these values because they're inverses. But I just want to make a little comment here about the g function. Technically, the g function is a parabola pushed down 5 units. Alright, but we know that this fails the horizontal line test. This doesn't have an inverse. Hence, that's why they're giving you the restriction. This is not an accident. They have to do this, actually. We're saying x has to be greater than or equal to 0, which means that they're taking away this side of it. Because if x has to be greater than or equal to 0, you're just cutting it into 2 parts and taking the right half. Right? Because otherwise it doesn't pass the horizontal and vertical line test to be an inverse. Right? So that's why we're getting this side. So there's that guy, which is the flip of this guy. And there's this guy, which is the flip of this guy. And so you're going to get this, which is the g of x function. And again, if you remember, this line has to be able to sort of cut the two functions in half. Okay, gang, so that's how we know they're inverses, because they're reflections over the line y equals to x. Alright, that's it on this video. Catch you. Bye-bye.